So I'm Andy, and I'm a postdoc at Shedd Aquarium, and it's my pleasure to talk to you today about some of the conservation research we've been doing. And first and foremost, I want to throw a huge shout out to Candice. Are you here somewhere? Yeah, all the way in the back, woohoo. And it's CAI who's a co-author on this and has made the study absolutely far more robust, so when we publish this thing, it's going to be great. So sticking with the theme of this conference, which is a species in decline, I just like to well, I guess I should first introduce conch, because now I'm the first conch person. So conch is a large marine snail that eats, it's herbivorous. Like most snails, it tastes good. And like most snails, it's really easy to catch. It's sort of a deadly combination if you think about it. So they've been really, really heavily harvested in the Bahamas and throughout most of the Caribbean. The example I like to throw out is I'm 29 years old. And it's been protected in the Florida Keys my entire life because they recognized that it was in decline and crashing. It's still not back. So once this stuff is gone, that's it, man. They're not coming back in an appreciable time span. But rather than sticking with the sort of doom-gloom thing, I'd figure we could go with a more uplifting story, okay, which is the fact that in the Bahamas, they recognize that this resource is slipping away in a lot of places, and as such, they have a devoted campaign to try and make a difference. And I really want to point out that the last three things on here are all integrating science into conservation and management, and that's really great. So that's where we can sort of help out. So our research, what specifically am I going to talk to you about today that has to do with providing ecological knowledge that could be used for conservation? So we're doing surveys to simultaneously observe conch and quantify the benthic habitat. So we then want to take this data and expand it. And the way we do that is we built a statistical model to make ecological inferences useful for conservation. So taking the associations we find between conch and habitat and scaling that upward so it could hopefully be used to further guide studies and perhaps with a remote sensing product to project where conch populations are likely. All right, so again, to a species in decline. So this is a theoretical conch metapopulation, right? So we've got three different populations, and say one of them is fished, harvested. One of the fundamental pieces of information you need to know if you're interested in protecting that population is how is it being replenished. So what populations could be feeding larvae back into that population to restore it? And the big question there, before you can describe what those larval pathways are, is you have to know where the conch are. And the easiest way to know where conch are is to go out, send someone in the water, and look for them. So that's what we did. Drag someone behind a boat, they look for conch. But the goal, you can't go everywhere in the ocean, especially not on the timescales you need to protect a species that's in decline. So we want to also provide a product that could help perhaps describe where conch could be in those other populations that are helping pathways of replenishment. All right, so that's the overview. This is a challenge for conch, and I'm going to go from the terrestrial literature here. So from the book by Thompson, 2004, describing survey and techniques and whatnot for describing rare populations, set forth three different criteria. And if an animal matches any of these three criteria, you could call them rare. All right, so the first one is, are they patchily distributed across a large range? So here you see a couple pictures of lots of conch. However, most of the time when we're out on these surveys, we don't see conch. We just see, seagrass, occasional macroalgae, other things. So we can say with almost certainty that they are very patchily distributed where they occur. All right, up next, cryptic. They move slowly. They live in highly vegetated areas at times, and they like to burrow in the sand. So they get natural camouflage on them, and they like to hide. They're definitely cryptic. And finally, small population sizes. So I was talking with David Stedman earlier about a huge population size where there's conch just everywhere, but that's far from the norm because fishing has really taken a toll on these animals. So I'm giving this like a half check. But the case can definitely be argued that conch are a rare species, and this poses challenges for surveying for them. Right? So we're not trying to reinvent the wheel here or anything. The easiest way to survey for an animal that's living in clear, shallow benthic habitat is to drag someone behind a boat, and that's what Alan Stoner's been doing for a long time. They just describe where the conch are. So they used a fully stratified sampling design using a 1 minute by 1 minute grid, and then they use a single 1 kilometer tow from the southeast corner of that grid towards the center to try and describe what the population abundance is within that entire sampling unit. So that's great for rapidly covering a large amount of ground and describing where conch could be. However, if you're trying to build a species distribution model, you need variance within your sampling unit. So we split this up, the 1 kilometer tow, into 5. And then we did 5 tows that are within stratified random points, so each one of these points, but then proceeding in a random cardinal direction. And that gives us a stratified randoms design that better captures variability. Then we're also recording what the benthic habitat is, so we can have some predictors in our model. And then finally, we use the exact same sampling unit so that we compare our surveys against the previous decade of surveys as well. Okay, so what does the survey consist of? Dragging someone behind a boat, and then we have a camera on a board. The most important person or component of this whole thing is the observer. We have yet to have a computer and an algorithm which does a better job of picking up complex patterns within the bottom than the human eyes. But we also have that person counting conch and then a visualization of the bottom so that they can just concentrate on their job and not have to worry about anything else. We drag them with a rope of known length, and then we have a GPS on the boat. So ultimately, what we're getting out of this is accounts of conch along with habitat that's identified clearly in space with the GPS. All right, so what's it look like? Here's a video. Hopefully it works. So we've got a boat dragging a person, and this is in some high current stuff, so not going all that fast, but it looks cool, and it's fun, and you collect really good data. So that's over a shallow area. Then we've got some more standard deep stuff, and then some really artistic videography work by Nate, which is why I included this little snip in here. He gets really close into Matt's face here, really up close and personal. Yeah, pretty fun. Okay, so where have we done this? So the Shed Aquarium has a research vessel, the Coral Reef 2, which is able to go out and act as like a mothership in a bunch of different places in the Bahamas. So far we've done the survey in the Sandbores, down at the southern tip of the tongue of the ocean, then a little bit in the Exumas, and then Candice again, and CEI brought this up into the Schooner Cays. All right, so another video. I hope this works. Oh, it does. Great, so this is just an image of a video of part of a tow, like 200 meters or something like that, just showing sort of how the habitat changes over tow. And then this is a much better and easier way of displaying what we see. So this is a composite image, and I put in these little yellow fingers here to sort of provide boundaries between the habitat. So here, I know it's sort of unclear because there's bright lights and everything. We've got seagrass, and then sand and some seagrass. Then we've got some macroalgae, and then we've got macroalgae over rubble. So this is a great way of just splitting the tow up into very well-defined units of habitat. And they're also, we're in the process of making a ton of high-resolution maps of the area as well, so we can much better and more precisely describe exactly what the distribution of habitat is. All right, so why is this data useful? So I've gone through about 60,000 meters of tows so far, and that's we have like 300 kilometers still to process, so that's a lot. But that's still a drop in the bucket. This is nothing compared to all the habitats that's out there, and so we want to use the lessons we've learned from the surveys we've done so far and expand that out. So we want to move our data out into a better way of describing what the populations could be throughout the Bahamas and perhaps around the Caribbean. And to do that, we built a statistical model. I'm not going to go into details because people get angry if I start saying numbers. So instead, I'm just going to say it's a generalized linear model with a Poisson fit, and the response variable is conch per meter. And then the predictive factors are different habitat descriptors, which I will now go into. All right. So we split this up into 3 different categories of factors. So each one of the little black boxes with a word in it is a factor. So starting from the ground, just how did we describe the ground through the tows? So we've got boulders, sand, and then 3 different grades of rubble. So that's great for the ground. Then we move up, and we talk about what's on top of the ground. A lot of the time, there's nothing. Then you've got fun little sand features, the mounds from like peanut worms and stuff, really cool. Various corals, and then we use 3 different grades of macroalgae and seagrass as well. And the reason we didn't split this up at the species level is we wanted to have some agreement with some of the massive remote sensing projects that already exist, so like the Bahamas Biocomplexity Project and Force and all of that. They use 3 different grades of seagrass. So we hope to be able to translate our different factors into things that the remote sensing products could use. And then we also have a third category. And that third category is describing the physical environment. And so my PhD was in biophysical interactions. My old boss would have an absolute hissy fit if I failed to mention the physical environment. So when you're going through the Exumas, one of the things we notice is there's a bunch of really deep, fast-flowing channels that separate the sound from the banks. And in proximity to those channels are where we found a lot of conch. So we wanted to also include that as a factor in the model. So we just measured the distance from the centroid of a toe out to the channel and threw that into the model. So then we have 2 more factors. We've got the proximity to the channel, and then we have the habitat diversity, also like a pseudo-fragmentation index thing, just looking at the number of transitions we had between habitat types on a toe. All right, so those are our factors. We've got 16 of them, and they are, again, describing conch abundance, or that's the hope. So which ones came out significant? These 5, and that's it. So what direction was the association that the model projected? So positive association here means that these habitats or features are associated with more conch, and the one negative is associated with less conch. And the one negative makes sense, right? Because they're slow moving, they like to eat vegetation, so if there's no vegetation around, I mean, why would they hang out there? Not even a little bit of macroalgae, that would suck. The 2 other grades of seagrass here were no surprise whatsoever because the largest aggregations of conch we've seen were over medium and dense seagrass. Then also, both of these cool ecological features that we identified came out significant, which was really lovely, because it's always important to include ecology in any sort of statistical model of species distribution. And none of the ground cover came out significant. So conch can be found in a lot of different ground types. They don't mind mud, sand, rubble. It's all good. All right. So some conclusions from the talk. Yeah, I know, that's bad. So what are the take-home messages here? So we identified association between conch and habitat. So what are those associations? Man, they love seagrass. That's what they're looking for in a home. Also, they like to eat. Seagrass is a highly productive environment. There's lots to eat there. However, they're also looking for more diverse habitat. So they want their dense seagrass, but they also want, to be able to transition around, maybe go climb up on the sand or something like that when they're tired of eating. And finally, a strong current. So all of this really makes sense as well. If you think about Pete Mara's talk that opened up this whole conference, he was talking about sampling during very specific times. And we sampled exclusively, or at least the shed cruises, during the spawning season. And they emerge from these dense seagrass beds, come up on the sand, and lay their eggs. If they're also near a strong current, that gives those eggs a better shot of dispersing out and elsewhere. So it was really refreshing that we had, some completely intuitional findings that we were able to quantify and put numbers on. And we hope to make that much more robust in the future as we expand out the surveys. But overall, this is just a simple, low-cost, easy system for surveying shallow benthic habitat. It doesn't get much better than that to be able to go out and collect data at not super expensive rates and turn that into a lovely species distribution model that we hope to improve on in the future as we continue this going on. And also, this is applicable in places other than the crystal clear, warm waters of the Bahamas. So when we were testing this out for the first time, it was me being dragged behind a boat in 10-foot visibility in freezing cold Lake Michigan. And we still managed to get out some solid topography. I guess, I don't know if you can actually see that, but this is over a really cool bank feature. So hopefully other people could use it as well. And with that, acknowledgments from wise old owls, Alan and Chuck and Chris, and also everyone who helped us out in the field and the boat. And I've got 5 minutes for questions.